Dear children, welcome to today's class. Today we learn the general trends in the modern periodic table. First, let us study about number of shells and valence electrons. As we go down a group, number of shells increases and number of valence electrons remains equal to the number of the group to which the element belongs. So when we go down a group, number of shells increases. The number of valence electrons in a group remains the same and it is equal to the number of the group to which the element belongs. Also, number of electron shells in a given element equal to the number of period to which it belongs. So, the number of shells equal to the number of the period to which an element belongs. For example, let us take the case of chlorine. Chlorine, its atomic number is 17 and the electronic configuration is, as you all know, it is 287. What is the number of valence electrons? Number of valence electrons equal to 7. Therefore, 7 number of valence electron means it belongs to group 7. So remember, number of valence electron equal to group number. Then how many shells are there? When you write the electronic configuration of chlorine, we got it as 287. That means it has 3 shells, K shell, L shell and M shell. So number of shells equal to the period number. Here the period number is 3 since it has 3 shells. So while writing the electronic configuration of an element, we can understand the group number and the period number to which the element belongs. Here we can say that chlorine belongs to group 7 and period 3. We say that it belongs to group 7 since it has 7 valence electrons and it belongs to period 3 since it has 3 shells. On moving from left to right in a period, number of shells remains the same. For example, in the third period, number of shells remains 3, that is equal to the number of period. In the fourth period, number of shells remains 4 and in the fifth period, number of shells remains 5. In a given period, number of electrons in the valence shell increases from left to right. So, the number of valence electrons increases from left to right in a given period. Let us study the trends in valency. Valency denotes the combining capacity of the atom of an element. It is equal to the number of electrons an atom can donate or accept or share. On moving down a group, valence electrons remain the same. Therefore, valency in a group remains the same. So, in a group, valency remains the same. If it is group 1 elements, all the elements will have the same valency. If it is group 2, all the members will have the same valency. In a given period, valency increases up to group 14 where it becomes 4 and then it decreases. That is, in group 17, it becomes 1. So, in a period, valency increases first and then it decreases. Valency first increases and then decreases. It increases up to group 14 where it becomes 4. That means up to 4 the valency is 4 up to group 14. the valency become 4 and then it decreases. And when you take group 17 elements, the valency becomes 1. And what about the group 18? Group 18 elements are known as noble gases or inert gases. They are already stable. They have the stable electronic configuration. Therefore, their valency is 0. That's why they are known as 0 group elements. Noble gases are known as 0 group elements since their valency is 0. They do not combine with other elements. Valency depends on the number of electrons in the outermost shell, that is the valence shell. If the number of electrons present in the outermost shell are 1, 2, 3 or 4, then their valency is 1, 2, 3 or 4 respectively. If the number of electrons present in the outermost shell are 5, 6 or 7, then their valency is 8 minus 5 equal to 3, 8 minus 6 equal to 2 and 8 minus 7 equal to 1 respectively. And for inert gases, the valency is 0. So we can say that valency is either the group number or 8 minus group number. Next we have atomic size. As one moves down a group, the size of atom of successive elements increases. So when we move down a group from top to bottom, the size of the atom of successive elements increases. The size increases because of progressive increase in the number of shells. So we have studied that when we move down a group, the number of shells increases. When the number of shells increases, the size of the atom also increases. For example, in group 1, atomic size increases as we move from lithium to cesium. Group 1 elements are lithium, sodium, potassium, rubidium and cesium. So the atomic size increases when we move from lithium to cesium. Size of the atoms decreases when moving left to right in a period. When we move from left to right in a period, size of the atom decreases. This is because increase in the number of protons increases nuclear pull, which decreases the size. Thus, in a particular period, alkali atoms have the largest size and halogen atoms are the smallest. Remember this point. In a particular period, alkali atoms have the largest size and halogen atoms are the smallest. Next property is metallic character. Metallic character increases as one moves down a group. This is because when we move down a group, the number of shells increases, thereby the atomic size increases. When the atomic size increases, the outermost electrons are far away from the nucleus. Therefore, the attraction force between the nucleus and the electrons will be less. Thereby, the electrons can be easily donated. Elements which can easily donate electrons are known as metals. Therefore, we can say that metallic character increases as one moves down a group. On moving from left to right in a period, what about the metallic character? The metallic character decreases. On moving from left to right in a period, metallic character decreases. Today, we learned the general trends in the modern periodic table. I hope you understood the topic. Winding up for the day. Thank you.